Welcome friends, we are going through the lecture series on engineering graphics. I am Dr. Shivraj Narayan, Professor of Mechanical Engineering. Today we are going to learn an important curve in engineering, that is involutes. The objective of today's session will be to learn about the concept of an involute curve and its generation, as well as the method of construction of involute curves of a polygon and circle using AutoCAD software. So first of all, we should understand what exactly is an involute curve. Now suppose we assume that there is a circle and that circle is wounded or wound by a string. So what happens is the circle will have circumference. So that circumferential length will be the length of the string. So when we wound a string onto a circle, it can cover a distance equal to the circumference of circle. So what we try to do is, we try to unwound this string or the thread slowly such that it is always kept tight. So one end of the string will be attached to the circle and the other end will be free to move. So when we start unwounding the free end of the string, it will trace a path, and that path is called as involute. And it is evident from this animation. You are able to see a circle over here, and then we are assuming that there is a thread which is wound on it, and slowly we start unwounding it. So one end of the thread which is free, as you can see here, it is tracing a path, and that path is called as involute. So technically it is a path traced by the end of a string as it is unwound from the polygon or circle, keeping this string always tight. So this particular curve and its shape is particularly useful in gears, that is the design of gear tooth profile, as well as other mechanisms that are used in watches or clocks. Now in order to learn the construction of involute curves, we will go through these problems. The first one is to draw an involute of a square of side length 20 mm. So now let us move to the demonstration. So in order to draw a square, we will first draw a polygon, that is, we will go to the polygon command. It is asking us to define the number of sides, so define it as 4. Now the software is asking center of polygon. So whenever we are drawing the polygons in engineering graphics, we will be making use of edge option, which is given in the square brackets. So click on this edge, and anywhere on the drawing area you click to start or initiate the polygon. In order to get the perfect alignment of the square, make ortho on, and now you can see, you are able to see horizontal and vertical alignment of the sides of square. Now in order to define the side length, you simply type 20 and press enter. So we are able to get a square of the required dimension. Now what we do is, we assume that there is a thread wound on it. So what will be the length of this thread? It will be exactly equal to the side lengths of the square. That means there are 4 sides. So 4 into the side length will be the entire length of the thread. So one end of the thread will be connected to this square and the other end will be free to move. So that free end we try to unwound so that we get the involute shape. Now in order to do that, what we have to do is, we need to unwound this thread side by side. We will not be able to get this shape directly, we need to do this side by side. And in order to do that, we need to do some construction over here. So I need to extend the sides of the square. So in order to do that, first we'll make use of offset command. It is asking offset distance. So you can remember that for any polygonal shape, the maximum distance that the length that the string will have will be equal to number of sides into the side length. So we have a square of 20 mm side length. So square means 4 sides, so 20 into 4 is 80. So now what I'm trying to do is, I'm trying to create an offset of the square at a distance of 80 mm so that I can easily extend all the sides. So I have typed 80 and then I'm selecting this square shape and clicking outside. So you are able to see we got another copy of square. Now I need to extend each one of these sides independently, but as you can see over here, this square shape is basically a polyline entity. That means if I try to select one of the sides of the square, the entire square is getting selected. So we need to convert it into a single line entity, and for that we have a command called as explode. So I'm just typing X, press enter, select the square, and again press enter. And now you try to pick one of the sides. So you'll be able to see the difference. Now each of these four sides, they are independent entities. So you can make individual selections now. So what I will do now is I'll extend these sides one by one. So I'm making use of the extend command. I'm clicking on this, then the next side, then the next side, and the last one. So once we have extended all the four sides, the square that we have offsetted can be deleted. Now I'll make use of mtext command, and I'll write down the names. So we'll call this as endpoint A. I'll copy this and place it at the other corners. So this, double click and change it to B. Similarly, double click, change it to C. Double click, change it to D. So what we are trying to say is our string or the thread which is wound on it, it is exactly connected at this point D. That means one end is connected to this and the other end is free to unwound. So from this point D, we'll try to unwound the thread. So when I try to do this side by side or step by step, at a step, what I can do is I can only unwound one side length distance, that is from A to D. So in order to unwound this and keep the thread tight, that is the reason we have drawn or extended these lines. So what we do is we take this A as center, the side length AD as the distance, we draw an arc. So go to arc command, pick center option, define A as the center point, then the side length AD as the radius, and now you need to draw an arc. So we know that in AutoCAD by default the arc is drawn in the anti-clockwise direction, but here our requirement is to draw the arc downwards. That means the thread which is wound on the square, we need to unwound it like this. We will start from this endpoint D and we'll try to unwound it until it becomes perfectly tight or straight. So this movement is basically clockwise movement, and by default in AutoCAD we have anti-clockwise drawing of arcs. So in order to draw the clockwise arcs, what we do is we'll press Control key. Press Control key, then pick this endpoint and move the arc downwards. So you can see what we have done. We have unwound this thread length from A to D and made it perfectly tight. So I'll make use of trim command and remove this unwanted portion of line. So the length of the thread that we have unwound is only one side length. Now what I need to do, I need to unwound the next length of the thread, which is the next side. So that means AB is the next side, and we have already unwounded AD length. So that means this is one side length and this is another side length. So what happens in the case of involutes of polygon, when we try to unwound it, for every step one side length gets added up. So in the first step we just unwounded one side length. Now in the next step we will be unwounding two side lengths. This is the AD and AB is the another side length. So now take B as center. So I have made use of arc command, defined B as center, and use this two side length as the distance in compass, or in our AutoCAD it is the direct position, and draw an arc up to this line. So now what we have done is we have unwound two side length distance. So this is AB and this portion is AD. So wherever this arc cuts the line, that is basically our point on the involute curve. So I'll make use of trim command and remove this unwanted portion of the line and arc. So if you want, you can even write the names of the points. So copy, place the text over here, write this as P1. Again copy this. Copy the P1 text and place it over here. So this becomes P2. So till now we have unwound two side lengths. Now we need to move to the next step. So since we have already unwounded the thread length up to B, now we need to unwound it up to C. So now C will become center. Two side lengths distance has already been unwounded. Now we need to add one more side length to it. So this becomes two side length plus one side length. So C will be the center and the distance will be three side lengths, that is C to P2. So go to R command, center option, define C as center, CP2 as radius, press Ctrl key and draw an arc up to this line. So I'll copy this text matter P2 and place it over here, double click and change the name to P3. Use the trim command, remove the unwanted portion of line. So now we have unwound total of three side lengths. So this C to P3 distance is nothing but three side lengths. And now the last one is we need to unwound the last segment of the square, which is C to D. Three side lengths are already unwound and one more side length has to be unwounded. So totally it will be four side lengths. So take D as center, D to P3 as the radius, draw an arc up to the last line. So now whatever shape you are able to see is nothing but the path traced by the loose end of the string from this D until the last point P4. So I'll copy this text matter and place it over here, double click, edit, change it to P4. So this shape is called as the involute of square. So select these arcs, right click, go to properties, change the color, increase the line weight. So this is the involute of square. Then show the dimensions. You can take any one of the sides and show the dimension, and you can write down the name of the curve somewhere here as involute of square. So I hope you have understood how to construct the involute of square in AutoCAD. So I'll just quickly revise this procedure. Initially we have drawn a square and then we assume that there is a thread wound on it which is having one end fixed at D and the other end is loose. That loose end we try to unwound it, and when we do this unwounding we do it step by step or side by side. So first we unwound the side length AD. So that is single side length. So A as center, AD as radius, we have unwounded this. Then we move to the next point B and try to unwound the next side. So it becomes two side length distance. So B as center, BP1 as radius, we draw another arc. So two side length is unwounded. Then we move to the next point C and we try to unwound this CB length. So already two side lengths are unwounded. We add one more side length to it. So this becomes three side lengths C to P3. And finally, we unwound the four side lengths. So this is how we construct the involute of square. Now we will go to the second problem, which is on constructing the involute of a circle. Polygonal shapes, they have specific sides. So drawing the involute of such polygonal shapes is a bit easy, but in the case of circle, we don't have such sides. It is a curve. So we need to follow slightly a different procedure. So for that, now what is the given data? There is a circle whose diameter is 40 mm or radius as 20 mm. So we have been asked to draw the involute and as well as draw a normal and tangent to it at a point 100 mm from the center of circle. So let us see the construction of involute of a circle. So using circle command, first draw the circle. So radius is 20 mm. Then use a line command and then try to draw a vertical line which starts from the center and ends at the quadrant point on the circle. So for doing that, go to OSNAP settings, make center on, quadrant on. And now move the cursor over to the circle. The software will indicate the center point of circle. Similarly, it will show the quadrant. So this is what we are doing now. Why we have drawn this line is we are trying to locate the point which we are going to trace the path of. So wherever this line cuts the circle, that is the point P whose path we are going to trace. So now circle is basically a curve. So what will be the length of the thread that will be wound on it? And that will be equal to the circumference of circle, which is nothing but 2 pi r. So we need to find out the circumferential length. So for that purpose, we'll make use of calculator and I'll type 2 into pi into r value is 20. So this is 125.66. So now from this point P, I'll draw a horizontal line whose length is 125.66. Now what does this line represent? This line represents that once we unwound the thread completely, it becomes perfectly tight as a straight line. So the length of that thread will be equal to circumference of circle. That is what we have done. What is the next step? Now this circle and the line has to be divided into same number of parts. So first, in order to simplify our process, what I'll do is I'll divide this line into some number of parts. So make use of the divide command, select the line. It is asking to enter the number of segments, so I'm typing 8, press enter. So now what we have done is we have divided this line into 8 parts. Then make use of array command. We need to divide the circle also into the same number of parts. So I'm making use of array command, and what I'm doing is I'm selecting this line along with all the points. Similarly, select the vertical line also which we have drawn in the circle. Press enter, then it will ask you whether it is rectangular or polar. So click on polar. Then it is asking center point. So specify the center point of the circle as the center point. And by default, it will show you the preview of polar array with 6 divisions. But we have divided the line into 8 parts. So now click on this items option and type the number 8 and press enter. So you can see now the software has created a polar array with 8 such parts. Now what I'll do is I'll copy the text from the previous solution and place it over here so that we understand easily. So this is the center point of circle. So I'm typing this as C. And this is the point P whose path we are going to trace. And then I will call this as number 1, 2 and so on. So copy this and place it at all the locations. So this is 2, double click, 3, 4, 5, 6, 7, 8, and the end point or the end of the string, I'm calling it as A. Now what we have to do is we need to assume that we start unwounding the thread, which is basically on this circle, step by step. So in the first case, what we can do is we can unwound only a small portion of thread which is equal to 1 division. So before doing that, I'll also show the numbers on the circle so that it becomes easier. So I'm double clicking and changing the names. So we have changed the names. So what we are trying to do is we are trying to pick this endpoint P and we try to unwound this thread division by division. So one division is nothing but this P1 dash distance, which is basically a curve. So we try to convert it into a linear length. So for that purpose, what we are supposed to do is we need to take this 1 dash as center and we need to draw an arc. So how do we draw that? So we have already divided this line PA into equal parts. That is, we have made the division. So this P1 length is nothing but equal to this 1 dash P distance on the circle. So you can directly take this P to 1 as the distance, 1 dash as center, draw an arc. Now what I have done is, in order to avoid drawing those arcs, already I have divided this line into number of parts and I have shown points. Those points are already reflected on these lines that we have drawn using array. So whether you take 1 dash as center, P1 as the radius and draw an arc, you are going to get the arc exactly at this position. So you can directly count the division points and start drawing the curve. So in the first case, when we unwound the portion by one division, the point P will trace up to this location. Then we unwound up to the second one, then it will move on to the second point on this line. Then we unwound it to up to the third distance, then it will go up to the third division and so on. So in order to draw the curve, now directly I'll make use of spline command. I'm not drawing the arcs, but I'm directly drawing the spline command. So division by division we are unwounding. So first it will go up to this first point on this line. So it is not picking this point because in the OSNAP node option is off. So what we are doing, we are going to the OSNAP features and making this node option on. And now move the cursor over this. You can see the software is highlighting that point. So this is the location where the point P will be traced to after one division thread is distance is unwound. When we do it by one more division, this point P will move to the second point on this line. Similarly, it will go to the third point on the third line, fourth point on the fourth line, then fifth point on the fifth line, sixth point on the sixth line, seventh point on the seventh line, and eighth point on the eighth line. So now once you have done the drawing of all the 8 points, you need to close this. For closing, click on this end tangency option, make ortho on, and then just move the cursor horizontally and check how is the shape of the curve. So this is not looking correct. Then you move it downwards, then you are able to see a perfect shape of this curve. So once we get the shape, you can click anywhere on the screen. So that will terminate the spline command. So whatever is this shape is basically the involute of circle. Now what we have done is we have drawn this entire length of the string at each one of the division point, which is unnecessary. So we need to trim this, and when we try to select this line, entire shape is getting selected. So this is where we need to again make use of explode command. So type X, press enter and select the structure, press enter. Now you can see each individual line becomes independent entity and you can do the trimming. So make use of trim command and remove this unwanted portion of the lines. And also you can delete these points which are not needed. Then select this curve, right click, properties, change the color, apply the line weight. So this is how the path of point P is traced, and this is called as the involute of circle. Now apart from this, we have been asked to draw a tangent and normal to this involute curve, and the distance is given as 100 mm from the center of circle. So make use of arc command, center option, pick center of circle, make ortho off, then type 100, press tab key, and draw an arc. So what we have done, with C as center, 100 mm as radius, we have drawn an arc on this involute curve. So I'll write down name, I'll copy this C and place it over here. This point we will call it as X. The next step is join x with x using a straight line. So I'll make intersection on. So wherever the arc is intersecting the involute curve, pick that point and join it with center point C. So we have joined x with C using a line command. Again, go back to OSNAP features, make this midpoint on. Now what we need to do is, using the midpoint of this line, we need to draw a semicircle such that it should cut the base circle. The circle on which the thread is wound, it should be cut. So what is to be done? Using the midpoint of this line, we need to draw a semicircle such that it should cut this base circle. So what I do is, now I'll make use of circle command, define the midpoint of this line. Midpoint is indicated by triangle symbol. So midpoint as the center and the radius up to x, draw a circle. And then you can trim the other side of it. So we get the same output. So we have drawn a semicircle using this midpoint. Now this semicircle is cutting the base circle at one point, and that is this location. So wherever this is happening, we will designate it as point N. Double click, type N. Now join N with X using a line. You can see the angle is shown as 79. So join N with X and extend. So you can type in the angle as 79. Line. So this line is now the required normal. I will copy the text X and place it over here. Double click, change the name to M, and a line perpendicular to this normal NM will be the tangent. So go to the line command. Now it should show us the perpendicular icon, but it is not showing. So we go to the OSNAP features, make everything off except perpendicular. And now move the cursor over this line. You are able to see the perpendicular symbol and draw a line. Next, mirror this line on the other side. So go to the mirror command, select this line, press enter. Now it is asking you to define the mirror line. So our normal NM acts as the mirror line. So I am making endpoint on. It is asking whether we want to erase the source object. So by default it is no. So click on no. So we got the tangent, but this tangent line should pass through X. So for that, make use of move command, select the tangent line, pick this point and place it at X. So this is the required tangent and we'll give name as ST. So double click, change it to S. Similarly, double click and change it to T. Then select the normal as well as the tangent. Right click, properties, change the color, change the line weight. Then again you can make use of the copy command. We need to show the points on involute curve. So I copied this P and I'll write this as P1. Copy this P1 and place it at the remaining points on involute curve. Double click, edit and change the names to P2, P3, P4 and so on. So once we have completed this naming of points, the next portion is dimensions. So type dim radius DRA and you can show the radius of circle. So DRA, select this circle and show this radius 20. Similarly, you can type dim linear and show this 125.66 distance, and the tangent and normal distance can also be shown. This arc is 100, and at the end you need to write down the name of this curve. So I'm copying this and placing it over here. This is involute of circle. So I hope you have understood the procedure for construction of involute of circle as well as to draw the tangent and normal, and earlier we have seen how to draw the involute of square. Square is a polygonal shape. So similarly we have various polygonal shapes. We have triangle, we have rectangle, we have pentagon, hexagon and so on. Similar procedure need to be adopted as that of square for drawing the involutes of triangle, pentagon, hexagon, heptagon and so on. Whereas for circle, which is a curve figure, you need to adopt this procedure. I hope you have understood this procedure. We'll meet in the next session on engineering scales. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.